Alright guys, today we're going to go back and review properties of exponents. I think everybody will appreciate that. I know we kind of just jumped into radicals and assume you guys remembered a lot of these things. So I just want to go over it again. So today's assignment is not going to involve radicals, but it's just going to involve the rules of exponents. So these are the same ones we talked about the other day, but that's what we're going to focus on. All of these except the fractional exponent, which is the last one here in this list, which is the same as rational exponents. Okay, so I'm going to break it down and give you examples one by one. And this is what your assignment will look like, examples like this. Okay, so the first one we're going to be talking about is product of powers, which is if you multiply, says if multiplying two numbers with the same base, you add the exponents. So we have 5 squared times 5 to the 6th power. Well, that would just be 5 to the 8th. Okay, and then let me expand here. On the y's here, if there is no exponent, there's an exponent of 1. And when we add all those y's, it would be y to the 8th. Well, let me just expand in case anybody needs that. Y to the 4 means we have 4 y's being multiplied times 3 more y's because it's y to the 3rd power times 1 more y. And if you count, you end up having 8 y's. So that's why this is our answer. So that's why it works. This is just a little shortcut. All right, when we have numbers, the numbers multiply normal. So you have 7 times 6. And your variables, that's y to the 5 and y to the nothing. So it's a 1. You add their exponents. You don't add the numbers, the regular numbers, it's just 7 times 6. But you add the exponents of the variables. So over here we have negative 3 times negative 5. That's going to be negative 15. Then you have x to the 2 and x to the nothing. So that's a 1. It's going to be x to the 3, right? We add. And then y to the 7 times y to the 6 will be y to the 13. And there is our answer. All right, let's review the quotient of powers, meaning when you divide them. If dividing two numbers with the same base, subtract the exponent. So we have y to the 6, and again, y to the nothing means y to the 1. So we subtract them, and that's going to be y to the 5th power. And just real quick, let me show you why that works. So we have 6 y's on the top and 1 y on the bottom, and we're dividing. So 1 y divides the other one out to give me a 1. But then we still have 5 y's on the top that do not cancel out or divide out. So we're left with a y to the 5th power. So that's why this works. So we have 6 to the power of 13 and 6 to the power of 2. We subtract them, and that's going to give us 6 to the 11th power. And then if I get my calculator here, let me pull it up. I know you can't see it, but I have it here in my computer. 6 to the power, and I don't think my calculator here lets me do powers. Darn it. Well, never mind, guys. We'll leave it at that because right now I don't have a calculator that does exponents unless I want to multiply 6 times itself 11 times. I kind of don't. All right, now we're dividing numbers, the big numbers, the big base numbers like that. You have 10 divided by 15. So those simplify to a fraction. You find the greatest common factor between both of them, and that would be 5. So 10 divided by 5 is 2, and 15 divided by 5 is 3. That's how you simplify a fraction, right? Then you have a to the 7 and a to the 5. So we subtract, and we end up with an a squared. Because it's a positive 2, it goes on the top. If it would be negative, it goes on the bottom, and then you would change it to positive. And then the b to the 9 would cancel out with the b to the 9 on the bottom. So it's just 2/3 a squared. All right, 0 power. Any non-zero number with an exponent of 0 is equivalent to 1. So anything raised to the power, any number raised to the power of 0 is 1. Let's explore why. Okay. So the rule here for division that we just did right here, the quotient, we subtract their numbers, right? Their exponents. Well, we have a to the 2 and a to the 2. 2 minus 2 is 0. So that's a to the 0. Anything to the 0 power is 1. But why? Well, if you have 8 squared, that's 64. Divided by 8 squared, that's 64. Well, what's 64 divided by 64? 1. That's why anything raised to the 0 power is always 1. So here we have an expression inside parentheses, all raised to the power of 0, so it equals to 1. We have 8x times x to the power of 0. Now here, be careful, because the exponent 0 only belongs to the x. If it was like this with parentheses, right, then it would belong to both of them and the whole thing goes to 0 like it went here. But because there's no parentheses, it means that only the x has an exponent of 0. So that means we're going to have 8 times 1. That x to the 0 goes to 1. Well, 8 times 1 is just 8. And then you add a 5. 8 plus 5 is 13. Negative exponents. If any non-zero number a is raised to a negative exponent, place the power in the denominator to rewrite the power with the positive exponent. Okay, so we have to change it to the denominator. The denominator is in the bottom. Once you change it to the bottom, then it becomes positive. Let's explore why. So here, well, let me do the exploration first. So we have b squared. That means b times itself twice. Then b, 1, 2, 3, 4, 5. Well, that cancels that out. That cancels that out. And we're left with 3 b's on the bottom, right? Or b to the third power. Now, there's nothing on top. That doesn't mean we don't have anything. This actually divided to give me 1. And this divided to give me 1. 1 times 1 is 1. So we're left with 1 over b to the third power. Now, if we're just doing the shortcut, that's b squared divided by 5, b to the fifth power. We subtract them and we get b to the third power. Well, we know that we do not leave it as a negative. We move it to the denominator, make it positive, and then put a 1. See how you end up with the same thing? So we don't want to write all the b's every time. We just want to do the shortcut. So here, 2 raised to the negative third, we're going to make a fraction. We move it to the bottom, and then we make that positive. Now, 2 times itself 3 times. 2 times 2 is 4, times another 4. Times another 2 is 8, right? That's our answer. Then we have a negative 3 to the negative 3. So that's going to be negative 3 to the third power. Once I move it to the denominator, it's positive. And then we can actually do negative 3 times negative 3, which is going to give me positive 9 times another negative 3 will give me negative 27. So we can write it like that, or we could put the negative right in the middle. We can even move the negative to the top. Either way, it's all the same thing. Negative 127. All right, power of a power. When I have, if raising a power to a power, multiply the exponent. So you have x to the 2 times, raised to the power of 8. So then we're going to, wait, I think I just messed that up. No, not sure what happened. If I accidentally closed it, let me open it again. That was some technical difficulties. Let me present again my window. Okay. Okay, I am in the right one. Okay. So I'm not sure what I did there, but that was interesting. So we multiply their exponents. It's going to be, oh my gosh, why do I keep putting equals? X to the power of 16. If we have y to the negative third, negative 3 times negative 4 is positive 12. Okay, so y to 12. And now if we have more than one term, find the power of each factor in the parentheses and multiply. So we're doing both. This one has to be multiplied in. I like to think about it oh my gosh, think of it as distributing our exponent. So the 3 is gonna be distributed to the exponent of 4. Well, 4 doesn't have an exponent, so it's a little 1. Then to the x, and then to the y, and then to the z. That's going to be 4 raised to the 3, x raised to the 9, because we multiply the exponents, y raised to the 3, and z raised to the 3. Okay, so, the only thing I can simplify there would be the 4. That's going to be 4 times 4 is 16 times another 4. Let me use my calculator here, which I think I closed. And I should know, but I can't. I think it's 64, but I just want to double check. Times 16 times 4 is 64, yes. So 64, and then the x and the y stay the same, and the z stay the same. Okay? All right. Then we have here, it's going to be 7 raised to the 1, x raised to the 1, and then we distribute that negative 2 inside. So 7 is going to be raised to the negative 2, x is going to be raised to the negative 2, and y is going to be raised to the positive 4. Okay? Now we don't want to leave our negatives the way they are, so we move that 7 to the bottom and then make the exponent positive. Move that x to the bottom and make that 2 positive, that exponent. And then that y to the 4 is already positive, so it stays where it's at. So our answer is going to be y to the 4, and I don't really need that 1 in the front. 49 x squared, right? So here, 6 has an exponent of 1, and everything else has an exponent, so I don't need to add 1. And we're going to multiply the exponents. So it's going to be negative 2 times 1, negative 2, negative 6 times negative 2, positive 12, positive 14, and 0. Okay, so we simplify that. That's going to go down because it's a negative. So it's going to be 36 because 6 squared is 36. Since it's a negative, 2 is going to go to the bottom. That x12 is positive, so it stays. Y to the 14th power stays. And then z to the 0 becomes a 1. So if I want, I can put a little 1 in the front, but I don't need it. There's our answer. Okay, now same rule. If you have an exponent outside, we multiply to the exponent inside. If it's a fraction, then both the numerator and the denominator get that. So then here we're going to have 3 raised to the power of 2 and 5 raised to the power of 2. So that's going to equal 9 over 25. Over here, we have, don't forget, everything has an exponent. The 2 has an exponent also. 2 to the power of 2, 5 to the power of 10, right? Because we're multiplying that 2 to all the exponents. B also has an exponent of 7, so 14. Okay. We can only simplify the 2, right? 2 squared is 4, and there's our answer. Okay, here we're going to have 3 to the power of 3, 9 to the power of negative 12, b to the power of 21. We don't want a negative. It's going to be 27 over a to the positive 12, b to the 21. Only the a had an exponent of negative 12, so only the a moved. All right, almost done. A to the 2 times 6 is 12, and they're both negative, so negative times a negative is a positive. Negative times a negative is a positive. Negative times a negative is a positive. Okay, and since all our exponents are positive, they stay where they're at, and that is our answer. Okay, hope you. If you guys have any questions, please ask in class, and I'll have this document attached for the notes.